Hello everyone! The hybrid system described in the previous lesson solves users' concern about message confidentiality and integrity on its way from the sender to the recipient, but it still does not answer the question of how parties know that the others are really who they claim they are. One way to achieve this is through establishment of a public key infrastructure. This lesson describes the need and the idea behind public key infrastructure, the contents of public key certificates, and shows how to check the validity of such certificate. Users of a public key infrastructure require confidence that the claimed keeper is owned by the correct remote subject, person, or system with which the secure communication is to be used. One way this confidence can be obtained is through the use of public key certificates, which are data structures that bind public key values to their owners. Digital public key certificates follow the same concepts used by many physical documents that people possess. A passport, for instance, is issued by a country's government and contains a lot of information. Information about establishing identity, such as name, date, and place of birth, and fingerprints. Information authorizing actions, such as travel to other countries or exercise of diplomatic duties. And the information on the validity of the document. Usually, other countries recognize the authority of the issuing country and accept passports as valid identification documents. Certificates are electronic documents issued by a certification authority, proving the ownership of a public key by a particular subject, person, organization, or device, and assigning actions that the subject may utilize the key for, that is, encrypt session keys, encrypt data, create digital signatures, etc. In a digital world of today, many countries are issuing digital identity certificates to their citizens for remote access to public administration services, effectively combining the purposes of physical ID documents and public key certificates. The certificate authority may be any organization of any size that is issuing certificates. A security-focused company to website owners, state to its people, company to its employees, an institution to its researchers, or universities to students. A set of roles, policies, hardware and software, and procedures needed to create, manage, distribute, use, store, and revoke digital certificates, and manage the public key encrypted communication in general is called the public key infrastructure. A typical certificate can be easily found in web browsers under the lock icon on the address bar. It contains a lot of information about the client and the certification authority. We will look at the standard contents of a typical certificate in detail shortly. A web browser ensures that an HTTPS web server you're trying to connect to is authentic by checking the validity of its certificate. This assures the user that their interaction with the website has no eavesdroppers, and that the website was what it claims to be. An example of this is the Verify Security Certificates option to HTTP request, which is enabled by default. A typical certificate usually contains the public key of the client, the information of this key owner, the subject, the validity window of the certificate, the information on the authority that issued the certificate, therefore vouches that they have verified the identity of the subject, the digital signature of the issuer, the serial number of the certificate in the issuer's repository, the policies describing the key usages, and other auxiliary information. When a sender needs the intended receiver's public key, they must get that key with the certificate from the certification authority repository. Very often, certificates are not standalone documents, but form a chain of trust from the subject, the client, to the root certificate of the authority. The validation of the client certificate then implies the validation of all the intermediate certificates as well. As an example, let's check the validity of Wolfram.com domain certificate. Here is the certification path from Wolfram.com domain to the certificate authority root. The chain of trust in this case consists of 4 certificates: the client certificates of Wolfram.com, 2 intermediate certificates, and finally the root certificates of issuing authority. The validation process verifies that a given set of certificates does in fact form a chain of trust by checking, among other things, the following conditions. First, that each certificate in the path is unique. Next, that the client certificate is the target certificate for validation, that is the correct website domain we're trying to access, a person or a remote machine. Here it says wolfram.com. It also checks that none of the certificates have expired, that is, that their validity window and date is at a later point in time than now. And we see that none of these 4 certificates have expired. It also checks that the root certificate is a trusted certification authority. Browsers and other systems that need to verify certificates usually store a list of well-known certification authorities, like GoDaddy in this case and a few others. The root certificate is self-signed. That means that the authority basically vouches for itself, so the issuer and the subject fields of the root certificate should be the same in this case. Then it checks that the root certificate data is correctly signed. It extracts the public key of the root from the certificate, gets the signed data and the signature included in the same certificate, and checks whether they are correct with verified digital signature, and it gives true in our case. For all the certificates in between client and root, the issuer of the current certificate should be the subject of the next certificate. Here you can see that the first intermediate certificate is the issuer of our client certificate. You can check whether this holds for all the certificates in the chain with moving map function, and it gives true for our 3 certificates before the root. We also need to check that for all certificates, the signature of the issuer verifies with the issuer's public key. For example, the data in client certificate is signed by the first intermediate certificate holder. For all the certificates in the chain, this condition can be checked by applying verified digital signature with moving map function sequentially on every certificate in the chain, and it gives true for all signed certificates. If all the aforementioned conditions hold, the user can be sure that their communication with the server that hosts the domain, like Wolfram.com, is secure, and that any information they send, like login credentials, payment details, or other, will arrive to the server not tampered with and not read by any malicious eavesdropper. A public key infrastructure, together with hybrid cryptography discussed in the previous lesson, form the foundation of the secure communication on the modern web.